Next concept, imbibition. Imbibition means generally adsorption of water. So adsorption of water, not absorption, it is adsorption of water. So what is absorption? What is the adsorption? Adsorption means, for example, this is the plant body surface. The water molecules are reaches to just surface only, not enters into inside. So water molecules are generally reaches to surface. Then after these water molecules are reaches to inside. That is absorption. Adsorption means water molecules are reaches to surface of the body. Absorption means that water molecules are reaches to inside of the body. That is absorption. So common examples in our daily life activities that imbibition, dry seeds. Dry seeds adsorb water to swell, to germinate. So dry seeds are absorb water, then after, they are helpful for germination of the seeds. Next, wooden, in the rainy season, wooden doors are becomes to swell. That's why we cannot able to close the door properly. That is two examples. So this imbibition generates some amount of pressure. First one, imbibition pressure. Imbibition pressure. Imbibition pressure means imbibition generates some pressure, that is imbibition pressure. For example, this is the rock, this is the seed, dry seed. So this dry seed absorb water to swell, then after generate some pressure towards the rock. That's why rocks are broken down. That is soil formation. Rocks are broken down into small pieces, and rocks are helpful to formation of the soil. That is rock weathering. So this is soil formation, breakdown of the rocks due to the pressure exerted by the seed, or rock weathering of rocks. That is, here one dry seed generates 1000 atmospheres. 1000 atmospheres of, that is a pressure. So one dry seed generate 1000 atmospheres of pressure. Due to this reason, rocks are broken down to formation of soil. Next, heat is generated. Heat is generated. It means that imbibition, due to the imbibition, heat is generated. Generally, water molecules are, these are free water molecules, they can move in different directions. They have kinetic energy. That due to the kinetic energy, water molecules are free. These free water molecules are moves into different directions. These water molecules are generally reaches to inside. So these water molecules of kinetic energy changes into heat energy. This is heat energy. These water molecules of kinetic energy is changes into heat energy. That is, heat is generated. Next, increase the volume. Increases volume. In our rainy season, we cannot able to close the door properly because that wooden doors absorb water to swell. That is, increase the volume. That's why we cannot able to close the door properly. That is imbibition. Imbibition means adsorption of water. Generally, example, dry seeds and wooden doors. Imbibition then generate pressure. One dry seed generate 1000 atmospheres of pressure. This is useful for formation of soil rock weathering. Next, heat is generated. Kinetic energy changes into heat. That is, heat is produced by the imbibition. Increase the volume. Size is increases due to the swelling in the rainy season of doors. Next, osmosis. Next, water potential. Water potential. The water have some they have some potential. That is, water have some potential, do some work. So water have some potential to do some works. That is water potential of water. Generally, these are the water molecules. These are the water molecules. These water molecules are moves in different directions. These water molecules moves in different directions. These water molecules have kinetic energy. This kinetic energy which is helpful for movement of these free water molecules. I am talking about this is solvent, nothing but water. In that pure water, it is pure water. In pure water, more kinetic energy is there because free water molecules are more. That's why heavy amount of the kinetic energy also we are observed. This kinetic energy, these molecules, more kinetic energy is there means that is they have more water potential. More water potential. More kinetic energy is there, more water potential also is there. So more water potential means that is the more kinetic energy. More kinetic energy. Kinetic energy is more. That's why the water molecules are moves to in different directions. That is kinetic energy is more means water potential is also more. Water potential represented by that is the psi. This symbol psi. When we are discussing units, that is the Pascal, PA. That is PA. Here, pure water have high kinetic energy and high water potential. High water potential. So pure water have high kinetic energy and high water potential. So is equal to 0. It means pure water potential is 0 because we are not added anything, just pure water. So in the pure water, more number of free water molecules are present. That's why it is 0. Next solution. Any solution. I am talking about any solution. Any solution water potential is minus. It means -1, -2, -3, etc. Because in this solution added two things. One is the water, one more is the additional substance. So when we are adding additional substances, free water molecules are there decreases. That's why solution water potential is minus. So pure water potential is 0. Next, solution water potential is less than 0, -1, -2, -3 like that. Because in the solution we are added additional substance. Additional substances occupies more space. So in this water, in this solution, free water molecules are less. That's why -1, -2 and -3. Next, So factors affect water potential. Factors affect water potential. Some factors affect water potential. Some factors affect the water potential. Next, first thing is solid. Solid means generally psi s. Solid potential represented with psi s. In case solid concentration increases, water potential decreases. Water potential is decreases because solid occupies more place, so water molecules becomes to less. Solid concentration is more, water potential is less. Second one, that is the pressure. So this is pressure potential, psi p, that is pressure potential. So pressure increases and water potential also increases. It is positive effect, it is negative effect. So this is the negative effect. It is negative effect on water potential. It is positive effect on water potential. It is positive effect on water potential because pressure is more, water potential also more. Next, solid is more, water potential is less. That's why the water potential is equals to, what is that? Potential of solids plus potential of pressure. This is very important thing. So water potential is equals to potential of solids, solid potential and pressure potential. Next, one more thing. The movement of the water potential, the movement of the water. For example, this is the container. Here, water potential is more water potential or high. Next, water potential is low or less. So these water molecules are moves from higher concentration to lower concentration. Higher concentration to lower concentration. So the movement of water from higher water potential to lower water potential. That is, so water always from higher concentration to lower concentration. In the water potential is more means more free water molecules are present. Water molecules are less because water potential is less. High water potential means high water molecules are free. Low water potential means that is the low water molecules, less water molecules are present. So here high water molecules are free. Next, here low water molecules are free. That's why the molecules are moved from higher concentration to lower concentration. It means higher water potential to lower water potential. That is water potential.